Good morning. I am Varalakshmi, Professor, Department of Civil Engineering from Mary Lakshman Reddy Institute of Technology and Management. Now I am going to discuss the topic of life of a reservoir and trap efficiency, which is a subject of irrigation and hydraulic structures, Unit 1. So, life of reservoir is an important factor that affects the reservoir capacity and life. So, in this lecture, we will going to discuss what is the life of reservoir and how it will be calculated and some problems also. Okay. Now, what is the life of reservoir? Life of reservoir means due to the silting of the reservoir, the capacity of the reservoir reduced in the long time period. So that time is called the life of reservoir. So due to silting, the capacity of the reservoir reduced up to 20% of the designed capacity. So the time taken for that reduction is called the life of reservoir. Okay. To allow for silting, a certain percentage of the total storage is usually left unutilized and it is called dead storage. As the time passes, more and more silting takes place and the live storage is also gradually reduced. In previous lectures, we discussed about the zones of storages of reservoir. In that, we discuss about three major storages: dead storage, useful storage, surcharge storage. So, dead storage water is not utilized for any purposes. Initially, the sediment deposition will occur in the dead storage. After fulfilling the dead storage capacity, it enters into the useful storage also. After filling up useful storage, the reservoir is terminated. But that means it not serve any purposes. So the reservoir life is closed. So in this lecture, we calculate that how many years will take to terminate the reservoir capacity. So the useful life of reservoir is terminated when its capacity is reduced to 20% of the designed capacity. The life of reservoir calculation is mainly depend on the trap efficiency. What is the trap efficiency? Trap efficiency is defined as the percentage of sediment deposited in the reservoir even in spite of taking precautions and measures to control its deposition. So trap efficiency is defined as the percent of sediment deposited in the reservoir. How to calculate the percent of deposition of sediment? It is calculated as total sediment deposited in the reservoir by total sediment flowing in the river. So trap efficiency is the ratio of total sediment deposited in the reservoir by total sediment flowing in the river. In most of the reservoirs, trap up to 90 to 100% of the sediment load flowing into them. Trap efficiency is a function of reservoir capacity and inflow. What is the capacity inflow ratio? That means Life of reservoir depend on trap efficiency. Trap efficiency depend on capacity inflow ratio. So, what is the capacity inflow ratio? The ratio of the reservoir capacity to the total inflow of water in it is known as capacity inflow ratio. So that means initial reservoir capacity is say 100 TMC and the annual inflow rate say 10 TMC of water. So 100 by 10 equal to 10 is the capacity inflow ratio. Trap efficiency is also known as the function of capacity inflow, capacity by inflow. So now we can draw a graph between trap efficiency and capacity inflow. The graph should be semi-logarithmic graph. In that graph, we taken capacity inflow ratio on x-axis, that means logarithmic side, and trap efficiency or percent of sediment trapped is on y-axis. The graph is in the shape of initially it is a fast increasing curve. After that, it reaches a stable, that means a straight line. Okay, the graph shows initially a fast growing curve line and after some time it reaches to a straight line position. So why the shape occur like that? Because the silting rate in the reservoir is more in the beginning and its capacity reduces due to silting. Later, the silting rate is decreased. That means at the initial days of the construction of reservoir, the sedimentation silting of the reservoir is more. After that, it decreases gradually and reaches at constant rate. Example, for 100 TMC capacity of reservoir is constructed in 2020. So, the silting is more up to 2030. Okay, up to 2030, 1,000 tons of sediment is deposited in the reservoir. Next, how much time will take that 1,000 TMC sediment deposition? Maybe it will take up to 2050. That means it will take in first 10 years or 10 years only 1,000 tons sediment deposited. But the same 1,000 tons deposition after 10 years it takes 20 years. So that's why, that is the reason the curve shape is like that, initially fast growing and after that it reaches a straight line. So the graph is evident that if the capacity reduces, trap efficiency reduced and lesser sediment is trapped. Thus, complete silting of reservoir may take a long time. Initially, the rate is high. Maybe it will take a lot of time to reach the trap efficiency, silting, complete silting of the reservoir. Next, you can check what is how the trap efficiency affect the reservoir. Two examples, we have two case studies here considered. First case study, on a big river, large stream is big river, construct a small capacity of reservoir. There, the capacity and inflow ratio is very small because reservoir capacity is small, 50. Inflow ratio is high because river is big. So inflows are more. Say 30. So what is the capacity inflow ratio? 50 by 30. So automatically it gives a less value. The trap efficiency also less because capacity inflow ratio is less. So the trap efficiency also less. Next, we will consider a second case. On a big reservoir, in previous case, we considered big reservoir, small, big river, small reservoir. Now, we consider a small river, a big reservoir. So, a small river is, a big reservoir is constructed on small river. In that, the capacity inflow ratio is very high. That means capacity is high. Okay, 100. River flow is small, 10. Automatically, the capacity inflow ratio will get high value. Similarly, in the proportionate, trap efficiency is also high. That means on the big river, small reservoir gives less trap efficiency. On the small river, big reservoir gives the high trap efficiency. Okay. Next, how to calculate the trap efficiency or life of a reservoir? So, first step, after fixing the reservoir capacity and knowing the inflow rate, calculate the capacity inflow ratio. Okay. So, first we will fix the reservoir capacity, say 100, and know the inflow rate, say 10. So, what is the capacity inflow ratio? 100 by 10 equal to 10. After getting the capacity inflow ratio by using the graph, obtain the trap efficiency value. Okay, for that 10 capacity inflow ratio, what is the trap efficiency? That value should taken from the graph. So in this graph, we are taking the capacity inflow ratio we are obtaining from this graph. So say it is one. What is the trap efficiency? So from that graph, we are taking the trap efficiency values. Next, divide the total capacity into suitable intervals. Okay, that means say that interval may be 10% or 20%. For example, the capacity of reservoir, we are saying that 100. So 100 to 90, 80, 70, like that, if we take 10%. If we take in 20%, 100, 80, 60, 40, 20, like that. So generally, we prefer 10 or 20% only. Okay. Next, assume that 10% capacity has been reduced due to sediment deposit. Find the capacity of 90% by inflow ratio and the corresponding trap efficiency. That means in first 1-2 steps, we calculated capacity inflow ratio and trap efficiency for full capacity of reservoir. That means 100 TMC. But after some time, that 100 is decreased to 90%. We are taking the interval of 10%. So that 100% is decreased to 90%. Again, calculate the capacity inflow ratio and trap efficiency. That means capacity 90 by inflow rate is not changing. Inflow rate depend on the water obtained in the catchment. capacity is depend on the sedimentation and design capacity. So here capacity is reduced, but inflow rate is same, 90 by 10. That is the capacity inflow ratio is 9. For 9, what is the trap efficiency? Take from the graph. That value should be take from the graph. Okay. So repeatedly you can do up to 10%. Calculate again 90%, 80% by taking like that and obtain the trap efficiency values for each interval. Next, for this interval of 10% capacity, find the average trap efficiency. So, after getting all trap efficiencies for each capacity, that means trap efficiency value for 100%, trap efficiency value for 90%, trap efficiency value for 80%. After calculating that, average the trap efficiency values. That means 100% trap efficiency value plus 90% trap efficiency value by 2. Next, 90% trap efficiency value plus 80% trap efficiency value by 2, like that. Average the trap efficiency values. So next determine the annual sediment inflow rate by taking water samples and drying the sediment. In previous lecture, already we discussed the measurement of sedimentation by using laboratory procedure. So, from that, collect the water samples from the reservoir at different places and at different depths. And after bringing that into laboratory, filter the water and calculate the weight of dry soil and wet soil. So by using that weights, the annual sediment inflow should be calculated, the weight of the sediment. Next, multiply that sediment transport value into trap efficiency and convert that sediment deposition into hectare meter units or other units. Next, divide the volume interval by the sediment deposited. So 10% of capacity, that means 100 by sediment deposited value, 90 by sediment deposited value, to get the number of years to fill this volume interval of 10% capacity. Repeat this procedure for further intervals. Remaining intervals also the procedure should be same. The total life of reservoir will be equal to the total of the number of years required to fill each of the volume of interval. So first we will get 100, how many years will take from 100 to 90. Next 90 to 80, how many years? 80 to 70, how many years? After summation of all years, we will get the total time period of the life of reservoir. Okay. So by following the above procedure, now we are doing the problem. The following information is available according to the relationship between trap efficiency and capacity inflow ratio. That means in the problem they have given the capacity inflow ratio and trap efficiency percent values. That means for 0.1, 87%, 0.2, 93%, 0.3, 95%, like that. Find the probable life of the reservoir with an initial reservoir capacity of 30 million cubic meters. Million cubic meters also known as MCM. If the average annual flood inflow is 60 million cubic meters and the average annual sediment inflow is 2 lakh tons. Assume a specific weight of the sediment equal to 1.2 gram per cc. The useful life of the reservoir will terminate when 80% of its initial capacity is filled with sediment. So what they asked first, find the lifetime of the reservoir. For that, what condition they have given? The lifetime of the reservoir will close when the reservoir capacity, 80% of the reservoir capacity filled with sediment. Okay. So what is the initial capacity? 30 million cubic meters is the initial reservoir capacity. Okay. So now we will calculate the lifetime of reservoir. So first they have given the average annual sediment inflow, 2 lakhs tons. That tons should be converted into grams. Okay. So that is 2 into 10 power 11 grams. Next, volume of average annual sediment inflow. They have given the average annual sediment inflow. That is converted into volume. Grams is converted into meters, is converted into meter cube. Okay. So 2 into 10 power 11 by 1.2 into 10 power 6. What is the value of 1.2? 1.2 gram per cc is the specific weight of the sediment. So the annual sediment inflow by specific weight will give the volume. So we are calculating the volume of average annual sediment inflow. Okay. That is 1 by 6 million meter cube. Next, they have given initial reservoir capacity as 30 million meter cube and annual flood inflow 60 million meter cube. Okay. Let us assume that 20% of capacity is filled up in the first interval. So next we can divide it into different intervals. So in the problem they have given that the reservoir capacity will terminate when 80% of initial capacity is filled with sediment. That means 100 minus 80, 20% interval we are taking. So 30 MCM, what is the 20%? 6 MCM. So first we calculate the 30 minus 20, first we calculate the 80%. That means 30 is the 100% capacity. Next we are going to 80% capacity. What is the 80% capacity? 30 minus 6. Okay. That is 24 MCM is the next interval. Okay. So first 6 MCM filled in the first interval. So first interval will calculate at 100%. Second interval calculated at 80%. Third interval calculated at 60%. Fourth interval calculated at 40%. And the last interval at 20%. Okay. So first interval calculated at 100%. Okay. Capacity inflow ratio. What is the capacity inflow ratio? It is the first interval. So the capacity of the reservoir is 30. What is the annual flood inflow rate? 60. 30 by 60 equal to 0.5. Next, we are taking the trap efficiency value. In the figure, in the table, for capacity G for 0.5, what is the trap efficiency percent? 96. So we adopted the 96. 96 is the percent. That should be converted into fraction. That is 0.96. Next, capacity inflow ratio at the end of the interval. Okay. Next, capacity inflow ratio at the end of the interval means when it reaches to 80%. When it reaches to 80%, what is the capacity of the reservoir? 30 minus 6. 6 is coming from 30 in 30, 80% in 80%. So in 30, what is the 80% value? 24. So 24 capacity by annual sediment inflow rate is same, 60. That is 0.4. Again, we are taking the trap efficiency value 0.4. 95.5 is the percent. So in fraction it is 0.955. So after that we are having trap efficiency for 100% 0.96, trap efficiency for 80% 0.95. Average the two values, we will get 0.9575. Next, what is the volume of sediment deposited annually till the 20% capacity is filled? That means 1 by 6 into 0.9575 million cubic meters. So, what is the number of years during when 20% capacity is attained? 6 by, what is the 6? 20% is the 6. So 6 by 1 by 6 into 0.9575. That is 37.6 years. That means when 30 MCM capacity is reduced to 24 MCM, how many years it will take? 37.6 years. That means in 37.6 years, that 30 MCM capacity of reservoir is reduced to 24 MCM capacity. Similarly, we calculate for second interval. What is the second interval? From 24 to next. Next is the 18. Okay. First, we calculate the capacity inflow ratio at 24 by 60. That is 0.4. Take the trap efficiency value from the table. It is 0.955. Again, calculate the trap efficiency at 18. That means we are calculating 80 to 60. Okay. So 18 by 60, 0.3. Take the trap efficiency value from table. For 0.3, it is 0.95. Average the trap efficiency. Then calculate the number of years during which next 20. That means 24 to 18 years or 18 MCM. How much time will take? 6 by 6 is the 20% constant value by 1 by 6 into 0.9525. So that is 37.8 years. That means 37.8 years is taken to reduce the capacity from 24 to 18. Similarly, for third interval and fourth intervals are calculated. After that, we are adding the all years 37.6, 37.8, 38.3 plus 40. Total 153.7 years. That means in 153.7 years, the 30 MCM capacity of the reservoir is reduced to 6 MCM capacity. So, what is 30 MCM to 6 MCM reduction will take time of 153.7 years. The same procedure also represented in table. So we follow the stepwise procedure or in the form of table also. Both are same. So first we are taking divided the intervals 100, 80, 60, 40, 20. We are taking 20-20 interval. 100%, the initial capacity of the reservoir is 30. Okay. So in 30, what is the 80% value? 24. In 30, what is the 60% value? 18. In 30, what is the 40% value? 12. So capacity is taken like that. Next, column 3 is obtained by dividing the column 2 by 60 million cubic meters. What is the 60 million cubic meters? Inflow rate. Okay. Column 2 by inflow rate. 30 by 60, 0.5. 24 by 60, 0.4. 18 by 60, 0.3. 12 by 60, 0.2, like that. Okay. Here one, it is missing. At 20, it is 6. You can add 6. Next, trap fourth column. Trap efficiency. That fourth column is taken from the given table. The capacity inflow versus trap efficiency in the problem. They have given one table. From that table, you can take the values of trap efficiency. In fifth column, average the trap efficiency values. That means 0.96 plus 0.955. It gives 0.9575. Next, 0.955 plus 0.95. 0.9525. Like that, you can average the trap efficiency value. Next, multiply the annual column 5th into annual average annual sediment inflow rate, that is 1 by 6. So 0.9575 into 0.1596. So like that, you can multiply each value of 5 into 1 by 6. We can obtain the sediment trapped per year. Next, column 6 by column 6. That means we are calculating for 20% reduction. So 20 is 80% filled up with sediment, assumed like that. So in 30, what is the 80% filling? 24. 30 minus 24, 6. 6 by column 6. So 0.1596 by 6 by 0.1596. The value is 36.6. 6 by 0.1588. Value is 37.8. 6 by 0.1566. Value is 38.3. Like that. So finally, we obtain the 153.7 years. So it is the calculation of the reservoir lifetime. You can say, you can take assignment of this problem. You can do the problem same as in the previous step. In previous calculated for 20%. Here they are given 10%. So you can take 10% interval. Okay. Thank you for listening. Thank you very much.